Hello everyone, I am going to be trying a different setup this time. So instead of you seeing my beautiful face, you're going to listen to my beautiful voice instead. So today we're going to be talking about the parts of expressions. So as normal, what I need you to do is go to the Google Classroom, go to the file in which you found this video, and go ahead and download the notes, print them out, or get them from your folder since we are now in in-person classes. After that, come back to this video and let's go ahead and start taking notes. So for this video, we're going to be talking about parts of an expression. So you're going to complete these notes as we go along, like you have been all semester so far. And let's talk about what it means to have variable terms. So that means that we have terms with a variable, or the ones that have letters. And those were going to be the 7x, the negative 5x, and the 4x. And we're going to write those down underneath where it says variable terms. So we have the 7x, the negative 5x, and the 4x. Next, we're talking about the constant terms. So those are the ones without a letter, or we call them variables. So, for example, we have 3 as a constant, 8 as a constant, and negative 1 as a constant. So we have 3, 8, and negative 1. And those are the examples of the constants that are in this expression. Finally, we have coefficients. Coefficients are a little different since they are a branch off of variables, and they are the number that's next to the variable. So in this case, 7 would be a coefficient because it's next to the x. Negative 5 is as well, and 4 is. So we have 3 different parts. We have the variable terms, the constant terms, and the coefficients. I'm going to be using those throughout this entire lesson. So if you do not understand it, you have to let me know as soon as possible so I can try and explain it to you a little bit better. Moving on. So whenever I tell you to simplify an algebraic expression, I am looking for you to do something called combining like terms. So that means that you're going to combine the variable terms and the constant terms. So using the expression that we just looked at, we're going to combine the variable terms and we're going to combine the constant terms, and we're going to have a simplified version. So what I'm going to do is I'm going to underline everything we said was a variable term, and then I'm going to put 2 lines underneath the constant terms. So 7x was a variable term, negative 5x was a variable term, and 4x was a variable term. And then we have 3 was a constant, so it gets 2 lines, 8 was a constant, and negative 1 was a constant. So what we're going to do now is we're going to add all the variables together. So we have 7x minus 5x plus 4x. So 7x minus 5x, that gives us 2x. We're going to look at the coefficients. So since we have 7 x's and we're subtracting 5 x's, we only have 2 x's left. So that's the same thing as 7 minus 5. So that means that we're going to have, for these two together, the 7x and negative 5x, that changes to 2x. And now we're going to add 4x to that. So 2 plus 4 is 6, and we're going to tack on the x, and that's it for our variables. So we've added the variables together. Now we're looking at our constants. So we have 3 plus 8. Well, 3 plus 8 gives us 11. And 11 minus 1 gives us 10. So we're going to add 10. 3 plus 8 was 11. And 11 minus 1 gave us 10. So that means that the simplified version of this algebraic expression is 6x plus 10. So in other words, we combined like terms. So I'm going to move on to the examples, and I'm going to task you with doing the evens. So I need you to finish 2, 4, 6, 8, and then once we move on to the second page, I will tell you which ones you need to finish there. So for number 1, we have 3x plus 6x. We only have variables, or we only have variable terms in this problem. So we just need to add the 6 and the 3 together. So what is 6 plus 3? You should be able to tell me it's 9. And then our variable is an x, so we're going to tack that on. And that right there is the simplified version of number 1, so that's our answer. Moving on to number 3, we have 7m minus 5m minus 6. So in this one we have variable terms and we have constant terms. So let's go ahead and use that line thing. So one line is going to be the variable, 2 lines is going to be the constant. 7m, is that a constant or a variable? Well, you should be able to tell me that that's a variable term, so we're going to underline it with one line. Negative 5m. Negative 5m is also a variable term, so it gets one line. Negative 6, that's a constant, so we have 2 lines. Now, we're going to combine the like terms. So 7m minus 5m. That's going to give us 2m. And then we're done with these two. And can we do anything with this negative 6? Are there any other constant terms? Well, your answer should be no. So we're not able to do anything with it. So we're going to leave it alone, and we're just going to put it on at the end. So that means that our answer for number 3 is 2m minus 6. So we can only combine things that have things in common. So the variable terms have the variable m in common. We cannot combine things that do not have the same letters. Moving on to number 5. We have 7p minus 1 minus 9p plus 5. We are asked to simplify each expression. So what we need to do, we need to underline the variable terms. In this case, it's 7p and negative 9p. Next, we're going to underline the constant terms. So we have negative 1 and 5. Now, since we've done that, we're going to combine the like terms. So we're going to combine everything that has a p. In this case, we have 7 minus 9. That gives us negative 2p. And we're done with the variables, so let's mark through them. Next, we're going to combine everything that doesn't have a p or doesn't have a letter. We have negative 1 plus 5. Well, negative 1 plus 5 gives us a plus 4. And that's the simplified version of number 5. And that's going to be your final answer. Moving on to number 7. We are going to change things just a little bit. And we're going to underline everything with an x once. And everything without an x twice. So, we have 5x plus 7y minus x plus 2y plus 3x. So what we're doing is we're going to identify everything that has an x, or everything that is just an x. So we have 5x, negative x, and 3x. Those are the only things that have an x. Next, we're going to do something with the y's. So let's circle them this time. So we're going to circle everything that has a y. We have 7y and 2y. We're going to combine everything that we underlined. So we have 5x minus x plus 3x. So what we need to do is say, well, 5x minus x, that gives us 4x. And then 4x plus 3x will give us 7x. Alright, and we're done with the x's, so we're going to mark through them so we don't look at them anymore. Next we have the y's. We have 7y and 2y. So we're going to add 7y and 2y together, and that's going to give us 9y. And that's the simplified version of number 7. We can't combine the 7x and the 9y because they don't have the same letters in common. If it was 7x plus 9x, of course we could. They're like terms, so we could add them. Alright, let's move on to the next page. And remember that you need to do number 2, 4, 6, and 8 by yourself before you turn this assignment in order to get credit for it. So again, moving on to the next page. Alright, so on this page, we're going to change some things. We are adding exponents this time. So, if you read this, it says, terms with the same exponents or combination of variables and exponents are considered like terms. So, that means when you combine them, we're not going to change the exponents. They don't change at all. Alright? We're just looking at the coefficients and the variables. As long as the variables are the same and they have the same exponents, you can combine them. So let's look at number 9. We have 5x squared plus 7x squared. Since it's an x and it's squared in both of these terms, we're able to add the coefficients together. So we have 5 plus 7. What is 5 plus 7? Well, that gives us 12. And our variable was x and it was squared. And this is the simplified version of number 9, and it's your final answer. Number 10 is yours to do by yourself. So number 11, we have 8c cubed minus 7c cubed plus 16c cubed. All of them have the same variable, which is c, and all of them have the same variable with the same exponent. So since the variable is c in all of these, and the exponent is 3 in all of these, we're able to just combine or add or subtract the coefficients. So we have 8 minus 7 plus 16. And if we do that, we have 8 minus 7 is 1, and 1 plus 16 gives us 17. The variable we were working with was c, and the power, or the exponent that was on c, was cubed. And that's our final answer for number 11. Number 12. We have 8k squared minus k minus 5k plus 7 minus 2k squared. So what we're going to look at, let's look at the first term. So the 8k squared. We're going to circle everything that has a k squared and only a k squared. So we have 8k squared and we have negative 2k squared. Now we're going to combine those two. So we have 8 minus 2. That gives us 6k squared. And the reason we're able to do this is because they both have a k and the k is squared in both of them. So now we're going to mark through these so we don't look at them anymore. We're going to move on to this negative k. So we're going to circle everything else that has only a k. So we have negative k and negative 5k. Well, if we add those two things together, because they have a k in common, we have negative 1 plus negative 5. That's the same thing as negative 6, and the variable was k. So we're done with these two. That only leaves the positive 7. So since there's no other constant variables, or constant numbers, we're just going to say plus 7 at the end, and we're done with this one. Since all of these numbers are marked out, I know that we've taken care of each of them. So this right here is our answer for number 12. Let's look at number 13 now. We have negative 4a squared b plus 7 plus 10a squared b. So we're going to combine the things that have the same variables and the same exponents. So a squared b. What else has an a squared b? Well, this 10a squared b does. So we have negative 4 plus 10. Well, negative 4 plus 10 gives us a positive 6. And our variables were a squared and b. And we're done with these two. The plus 7 is by itself. There's no other constant terms in this problem, so we just put plus 7, mark it out. Since all of these terms are marked out, I know that this is our final answer, and 13 is finished. So our final answer for 13 was 6a squared b plus 7. So now let's look at number 14. We have x squared. Is there anything else that has an x squared? Well, no, there's not. So we can't combine like terms with x squared, so it's going to stay by itself. Alright, so we're done with this one. Moving on to the next term, we have 2xy. Do you see anything else in this problem that has an x and a y? Well, the thing that's right next to it, negative 7xy. So, since they have the same variables, we're going to look at their coefficients, and it's 2 and negative 7. If we add those together, we have negative 5. The variables were x and y, and we're done with these two. We combine them. They're like terms, so we combine them. Finally, we have plus 4y squared. Do you see any other term with a y squared? Well, your answer should be no. So we're just going to add it to the bottom here and mark it out. Well, you might ask me, well, why don't we combine the 4y squared and the x squared? And the reason is because the x is not a y and the y is not an x. So it has to be the same letter for both of these. Well, you say, well, what about the exponent? It's the same. Well, it has to be the same letter and the same exponent. So that means that if I change this problem from, let's say the end was x cubed, they have the same letter, but they don't have the same exponent, so we still can't do anything with it. So this has to stay by itself. So again, this is our final answer for number 14. I want you to try 15 by yourself, and I also want you to try 16 by yourself. So you might ask me, well, Mr. Adams, what's the point of actually combining like terms? I don't get it. Well, the point is we're able to find perimeters whenever you move on to geometry next year. So a perimeter, if you remember, is the total distance around an object. So if we look at number 17, I'm only going to do 2 of these because we don't really need to touch on it as much. And I'm going to have you do number 18 and number 20 by yourself. Just make sure that you pay attention and that you combine like terms where you're supposed to. So if we look at number 17, we're trying to find the perimeter. And remember that we're going to add all of the side lengths together. So we're going to add this side length plus this one plus this one. And that's going to give us the perimeter of the shape. So, side length, we have 2x plus 1. That's this guy, and we've added it. We're going to add x. Alright, that's that side length. We're going to add 3x. That's that one. Now, this is very ugly. We have to combine like terms in order to make it prettier. So we're going to add everything that has an x. So we have 2x, x, and 3x. Well, 2 plus 1 plus 3 gives us 6. And it was an x. We're going to mark through those because we're finished with them. We now only have the plus 1. Are there any other constant terms? Well, no. So we're going to have plus 1 at the end, mark through it. That means this is your final answer. And we have that this is the perimeter of the triangle for number 17. Again, number 18 is yours to do by yourself. Make sure you pay attention to the like terms. Number 19. This is a rectangle. Alright? And if you remember, a rectangle have the same side lengths if they're opposite. So in other words, this y over 2 is the same length for over here. So it's not y over 2, y plus 2. And it's the same length for the opposite side. 3y minus 5, same length for over here. That's one of the properties of being a rectangle. We're trying to find the perimeter. So basically, what's the distance if you start here and you walk completely around? If you walk completely around this object, well, how far would you actually go? Alright? So we have y plus 2. That takes care of this side. We're adding 3y minus 5. Alright? We're adding y plus 2. And we're adding 3y minus 5. Alright? That takes care of all the side lengths. So you've walked all the way around this object. Now, we have to combine like terms. So everything that has a y, we're going to combine. So we have y, 3y, y, and 3y. So that means we have 1 plus 3 plus 1 plus 3. Well, that's going to give us 8. And our variable was y. And let's go ahead and mark through all of those so we don't consider them anymore. Alright? Next, we're going to look at the constant numbers. So we have 2 minus 5 plus 2 minus 5. So 2 minus 5 is going to give us negative 3. Negative 3 plus 2 is going to give us negative 1. And negative 1 minus 5 gives us negative 6. So that means that 8y minus 6 is the perimeter for number 19. And again, number 20 is yours to do by yourself. Whenever you submit this, please be sure to take a picture of your work and have problems 20, 18, 16, 15, 10, 8, 6, 4, and 2 finished by the time you submit this. Other than that, that's all I have for you today. And I hope you have a wonderful day.